Hey! So who should learn JavaScript? At least before you delve into JavaScript, you need to know some programming, just a little bit, or just some knowledge about programming. So in the list, at least you should know some HTML and some CSS, because these three usually work together: HTML, CSS, and JavaScript. In most cases, you will use them together. So if you really want to use JavaScript, especially in the web space, you need to know HTML and CSS in the list. I did a few introduction tutorials for HTML and CSS, and I'm providing the link here on the screen. You can just go there and see the links that will lead to HTML and CSS, and you will learn the HTML course. I think it's roughly 1 hour, and the CSS course is also roughly 1 hour. So in 2 hours, 2.5 hours, you can learn HTML and CSS, and then come back and we'll continue with JavaScript. Hey, and welcome back. So what is JavaScript? If you want to learn more about this JavaScript stuff, you just go to Wikipedia. Yeah, there is this page, and you'll find a lot, the history of JavaScript, a lot of information here about JavaScript. And then there's also this page on Mdn. So if you want a lot more information, you can go to the Mdn page on JavaScript, and you can also go to Wikipedia. So JavaScript is a lightweight interpreted programming language used for producing and manipulating web content. So it's not only limited to the web browser. You can also use JavaScript on mobile phones and other environments like Windows applications for Windows 8. There are also robotics that have been employing JavaScript. So it's not just limited to the web space anymore. So what are some features, characteristics, and facts of JavaScript? Well, it was created by Brendan Eich in 1995 at Netscape. JavaScript is standardized as ECMAScript. So ECMAScript basically defines the standards and the implementation of JavaScript. So JavaScript is just ECMAScript. So the latest released ECMAScript was ECMAScript 2015. So you can read about all of that here, things relating to the ECMA standards and the current version. So the one we will be using based on the Mozilla Developer Network is ES 2017, which is still work in progress. It will be based on the draft, and I will be following this documentation, so I will by default use the one that they have, which is ES 2017. So JavaScript is a high-level, dynamic, untyped, interpreted, multi-paradigm functional programming language. So let's continue in the next video and we see what the hell this means. See you then. Hey, and welcome back. In the last part, we say that JavaScript is a high-level, dynamic, untyped, interpreted, multi-paradigm functional programming language. So, what does it mean, dynamic? This means that it can add things at runtime. So it can manipulate and be manipulated at runtime. There are certain programming languages, once it is written, you can't add anything once it has been compiled. So JavaScript is not like that. It is dynamic. You can add things, it can manipulate things at runtime. Then, untyped. Untyped basically means that JavaScript doesn't care much for types. So types in programming are things like A good example, let's say C++, if you have to define a variable, it has to be defined using types. For example, integer, so you'll say int x to show that that's an integer. If it is a float number, a number with a decimal point, it has to be declared as a float. So basically, JavaScript doesn't really care much for types. There are a few data types in JavaScript, but they're not as strict as other programming languages like Java and C++. So if you ever hear anything about type, this basically refers to data types. So it is about data type, so it is types of data. So integers, floats, strings, booleans. So that's basically what it means. It is untyped. You don't have to declare a variable with a type. And then it is high level. So high level means that it is abstracted from the computer details. As a user, you'll just write basic JavaScript code. There is a lot of abstraction from the computer details. So we don't have to see the byte codes and the zeros and the ones. That's basically what it means as a high-level programming language. So it is interpreted. This means that you don't need to compile the code. So you'll just write it and run it. So you can just write and run it without having to compile it. Languages like Java, C++, you have to compile them before the application you made can be run. It has to be compiled. For JavaScript, you just write it and you run it on the browser. So that means it's an interpreted language. And then it's a functional programming. So the easiest way I can think of this is it's basically defined into functions. So grouping things, most of the implementations you'll do in JavaScript will be based on functions. So grouping different related kinds of codes. So that's a functional programming, or similar to what is called subroutines in C, whereby code is grouped based on what they do. So one function does something, another function does something. So it's a functional programming language. And then multi-paradigm. Multi-paradigm basically means that however you think you can implement something, that's how you will do it. There are no rules. There are no clearly defined ways or specific ways of doing things. Solve it any way you like. That's multi-paradigm JavaScript. So JavaScript is not picky. Okay, I hope you have a basic understanding of what all these are by now. If you don't, you can take any course online that deals with programming and you will get a better understanding of most of these concepts. So I will see you in the next video. Hey, and welcome back. In this course, we will be doing programming related things. That means we need tools for the job. We'll mostly need a text editor, a browser, and a way to debug any JavaScript issues that we will experience in future. So when I started, I said that one of the requirements for the course, at least you need to have some knowledge of programming. Plus, I also give you a link for my HTML and CSS course. So if you took those courses, you encountered all these things here except for Scratchpad. So a browser, I'm a big fan of Firefox. I usually use Firefox for nearly everything. My browsing as well as my initial development, I use Firefox. And I also use Chrome. So whichever you like to use. If you're on a Mac, you'll have Safari by default. If you're on Windows, you'll have IE by default, Internet Explorer by default. So browser, check, get one. Text editor. For text editors, we have Notepad which is free, which is awesome. This has everything you will need. Notepad++ is free for Windows. You can get this and use it for any programming that you will need to do. And I will be using Sublime Text. Sublime Text is, well, it's free, but if you don't buy a license, there is a prompt that comes up asking you to buy a license. So if you want to buy a license, you can get it for $70 if you want to get this one. If you're on Windows, you can use the Notepad++. It's free. The good thing about Sublime, it is cross-platform. If you don't like any of this, you can go online and try and find a free one for whichever platform you're using. There are lots of free text editors out there. Text editor, browser, check. Then browser plugins. So you'll need a way to debug code. So on Firefox, there is Firebug. Just get Firebug and install it. And then Firefox inbuilt developer tools. We also have the inbuilt developer tools. If you don't want to install any add-ons, you can just use this inbuilt developer tools for Firefox. So to open it, just press Ctrl+Shift+K. That's on Windows. On a Mac, definitely Control always gets replaced with a command. So Command-Shift-K. And then Chrome's inbuilt developer tools. This is one of the best developer tools around. So if you're using Chrome, this will be enough for everything you will ever need to do in terms of debugging. Press F12 to open the Chrome developer tools. Then we have Scratchpad. Scratchpad is like a text editor. So let's just go and see how Scratchpad is. So if I come here, I can open Scratchpad by pressing Shift F4 on my computer. The good thing about Scratchpad is that the code that I write, I can save it. For the others, developer tools on Firefox and developer tools on Chrome, I can't save that code. Once I run that code and I refresh the browser, that code is gone forever. It's like a text editor because I can save things. You can see I have save. I can also open file. So I can just use this one also as my text editor. So if I come here, for example, I can say alert to +2. And then if I run this, you'll see it just runs it directly here on Firefox, which is really nice. And I can also save this if I want to save it. And if there is any, and with this one, if there is any errors, like for example, it will just tell me, let's say I do 2 plus 2. I'm supposed to use braces for this. I'm supposed to use the brackets for this, and I've used braces. So if I try to run this, you'll see it tells me right here that there is some kind of error. No text editor can do this. So if you want things like this, you can also use Scratchpad to follow along with me once we start writing code. So I will see you in the next video, and I hope you have seen the tools that you'll need. So you'll need a text editor and a browser and a way to debug the code if there's any errors. So anything that you don't have, just download it and install it. Most of these are free. You can get all of this. There's always a free option for everything. So whichever platform you're using, get the tools that we will need. I will see you in the next video. Hey! So a brief about the JavaScript syntax. Instructions are called statements. So this is one statement, that's a statement, that's a statement, and this function that has these curly braces, this is a block. So if they have the curly braces, that is a block of code. So statements end in semicolons. And in the ECMAScript definition, it is said that the semicolons are optional, but always make sure you add them. And then you can create spaces in JavaScript by the tab key on your keyboard or the space bar. There's some spaces that are significant, others don't really matter. So you can add spaces here. If you want the code to look cleaner, you can add spaces. Some places spacing does not affect, but in this case, if you do that, it will be affected. So there are cases where space affects and spaces doesn't affect. So the spaces are called white space. So these spaces is what we call white space. JavaScript is also case sensitive. So that means if you have a variable and you have another variable this will point to two different variables. So JavaScript is case sensitive, so always keep that in mind. Okay, let's continue in the next video. Hi. Okay, so like any other programming language, you'll find yourself using comments in JavaScript. And there are single line and block comments. So a single line is just the 2 forward slashes, and then for a block comment, it is one single forward slash, an asterisk, and an asterisk, and a forward slash. So if I want to add a comment here, I can just add it there with forward slash there. That's a comment. That's a single line comment, and this will not be executed. It is just a comment that will let someone else reading the code know what's happening. So that's a single line comment. You can also have the block comment. So there. So comments are useful. They can help you understand what it is that you're doing, especially when you're writing lots and lots of code. You can use comments to explain what you're doing so that when you come back to the code in future, you will know what it is you are trying to do. Because in most cases, you'll find you write a lot of code, and if you write a lot of it and there's no way for you to remember what it is you are trying to do, you'll have a hard time trying to figure out what exactly that code does. So you can use comments by single lines, or you can use a block comment such as this one. Let's continue in the next video. Hi. So what is a variable? So in computer science, a variable is said to be a memory location. However, I do like this definition from Mdn, which says that a variable is a symbolic name for your values in your application. So you can use variables to represent specific values. So in place where you'd be using those values, you use the variable. So an example, so let's say you're building an application for people in a class. So you can use a variable for name. So when you use this variable for name, you can have a first instance of name, which can be one of the people in class. Let's say someone is called P. So in other places, you can also change the variable name to the other people in the class. So a variable represents your values. So let's go. So if I come here, you'll see all these fields. All of these are represented by variables. So when you sign up or when you sign into Facebook, your email is stored in a variable. Someone else's email is also stored in a variable. So the variable will change based on the value, based on the email of whoever. So all these are stored in variables. So let's say they want to use this in the application. Somewhere in the application, they will refer to the variable. Let's say where. So let's say the variable for this is email. The variable name for this is email. And the variable name for this one is password. So if you come to login, they will check if the variable is equals to what you have added and the password variable is equals to what you have added. And if that variable exists in the database and the variable for the password also exists in the database, they will let you in. And then they will use the variable for your name and the variable for your surname to show you your Facebook profile when you log in. So you'll see your name is somewhere there and your other profile details. So all of that is stored in a variable. So a variable must have an identifier. So if I was to declare a variable var name, this is the identifier. It is what identifies the variable. If you're new to programming, this can be somewhat confusing, but just think of it as a placeholder that can be changed. You can name your variables whatever you want, but there are certain rules. So a variable identifier can be alphanumeric and it can contain the $sign or an underscore, but it cannot start with a number. You cannot start a variable name with a number, but you can mix up things the way you want. So let's see some examples of names of variables. So just note that a variable name can contain both letters and numbers, that's alphanumeric, and then it can have the $sign also as part of the identifier name, and it can have an underscore. So let's see some examples of legal variable names. So here we have a var. So this is a declaration of a variable. You declare with the word var and then the name of the variable. So this is the identifier. And we say that it can be alphanumeric, it can have letters and numbers. So this one only has letters. So Dalmatians, var Dalmatians is a legal identifier. And then this one has both number and letters. So this is alphanumeric. You can name it Dalmatians 101. You can call yours whatever you want. Just give it whatever name you want to give it that has a letter and a number. So this one is also legal. It can start with an underscore. It can have an underscore in the middle. It can have an underscore in the end. Then it can also have this $sign in the beginning or even in the end. So variable cannot be a number. So like that cannot be a variable identifier, and it cannot start with a number. So it cannot start with a number, and it cannot be a pure number as the identifier for the variable. And also note that variable identifiers, since JavaScript is case sensitive, if you give two variable names the same name but in different cases, one is a capital and the other one in small letters, those will be two different variables. Okay, let's continue in the next video and we'll look at more about variables. Hi, and welcome back. How do you declare variables? To declare variables, you have different ways you can do it. In JavaScript, you can declare variables using the var keyword. You can also declare variables without using any keyword. And you can declare using the let keyword. So you can say var x is equals to whatever. In this case, this has been instantiated, but I will come to that later on. In this case, there is no keyword here. So this gives rise to what we call a global variable. So if you declare a variable without using any keyword, in this case, it will give you a global variable that can be accessed out of the scope of where this is. You'll see this in future and understand it better. And then we have the let. Now this is new in ECMAScript 2015. So that means it's not supported in some browsers as of now, but implementations are ongoing. So in future versions of web browsers, most of these features will be supported that are new in year 6. And as I said earlier on, in one of the earlier videos, I'm using the Mdn Javascript Documentation, which is written based on the latest draft of JavaScript, which is ECMAScript 2017. So there are certain features that we are going to encounter from ECMAScript 2015 as well as from ECMAScript 2017. And the good thing about the Mdn documentation is that they are labeled. So when we get there, I look at them and see what they say about each of the ones that are marked, and I will communicate the same to you. Okay, so we have variables declared using the var keyword without any keyword and the let keyword. So the difference between this and this is in scoping. So we'll talk about variable scopes. Basically, scope means where it has effect. Within which block does that particular variable has effect. So that is scope. And we'll look at variable scopes later on. So I don't like to make really long videos. So I'm going to end this video here. And then in the next video, I'm going to talk about variable instantiation and also about variable declaration. So you declare and instantiate. In this case, I declare the variable and I did instantiate it at the same time. So in the next video, let's look at how you can do without instantiating the variable. See you then. Hey, welcome back. So let's go to the browser and see all of this in action. So I will go to Firefox. Now, I will be using Firefox. If you don't have Firefox installed, go to mozilla.org and install Firefox. And the reason I will be using Firefox is because I want to use Scratchpad. And to open Scratchpad on Firefox, you'll just press Shift F4 on your keyboard. And this is what I will be using for some experimentations of the code and some demonstrations. So the first thing I want to do here, I'll just remove this. If you look at this documentation, you can see even in Mozilla they use things like console.log to show examples, but I want to use alert. So in my case, I will be using alert to show examples. So once I just say alert and I click on run, it will show me the alert here. So that's why I want to use it. I can just do things and test them immediately, and if there are any errors, it will also let me know using comments right here on Scratchpad. So if you want to use Scratchpad as well, you can download Firefox and follow along with me. Okay, So let's say we declare a variable. So you can declare a variable using the var keyword. So var a. So we've declared a variable var a, and we haven't instantiated the variable a. So how it works is this. First of all, you declare the variable so that the system can know that there is a variable called a, and then you give that variable a value. So in this case, I can say var a, then I can put it in a different line and say a is equals to 4. And then now if I do an alert a, we know that a is as a value of 4. So if I alert this, if I run this, it will give us the value of 4. Let me close that one. So if I run this, it gives us that value of 4. Okay. You declare the variable and then you give it an instance. So in this case, I declare the variable and give it an instance in the same line. So I can also do the same thing right here. So if I come here and delete this line, and I give this the instance of 4, I give it that value of 4, and then I run it, it will give us the same 4. If I change the value, maybe 1000, then I run, it will change the value. So let's continue from here in the next video. So as we said, a variable stores some value in memory. If I come here and I try to use the let keyword to redeclare this, the let does not allow us to redeclare the same variable identifier. So this is an identifier. So if I say let, this will be like redeclaring this because the value is already stored in the browser's memory. So if I come here and I run this, you'll see it gives us an error. It cannot redeclare a. So if you want to try an example with the let, we have to use a different identifier. Let's use b. And then if we come here and say b, then we run this. Okay, I think I used b at some point, and all of this is now being stored in the browser memory. You can see what a variable actually is. It just stores these things in memory until you change its value. So let me use c because I have used b and I have also used a. So c is not in the memory. If I come and I run, you'll see in this case it will run just perfectly fine. So this is a very good example for what a variable really is. And since the let keyword, which is different from the var keyword, does not allow us to change the value of an identifier within the same scope. So we look at scopes later on. Within the same scope, you cannot change the value of a variable that you have declared with the let keyword. And you've just seen a perfect example for that. So that's one reason why it would be better to use the let keyword. So as we saw earlier, we can also declare a variable without any keyword. It will still work. So I can say alert c, and if I run this, you see it gives us this one. If I change the value just to confirm and then run it, you see it gives us a different value. So you can see that declaring a variable with the var keyword gives you a variable that can be changed at any time. It can be mutated. A variable declared with the var keyword is mutable within that scope. If you use the let keyword, it will give you a variable that you cannot redeclare it using the same name. you can declare var x is equals to 10, then var x is equals to 20, but you cannot say let x is equals to 10 and then let x again is equals to 20. If you declare with this, this is just the same as this, except this one is a loose variable. This is a variable that is accessible from outside the scope of the code that it is running. So in the next video, I want us to look at something to do with undefined and reference, and something to do with the reference error. So I'll see you in the next video. Hey, and welcome back. So an undefined variable is one whereby you have the variable, you have declared the variable, but you haven't given it a value. You have not initialized the value of the variable. And then a reference error, this is just calling for a variable that does not exist. So let's take a look at some examples with the var keyword and the let keyword. So if I come back to Firefox, I will open Scratchpad, and you can open Scratchpad by Shift F4 on your keyboard. So the first thing I want to do, let me declare a variable x, and then alert the value of x. So this, let me just run it and you will see what it will tell me. So if I run this, you see it gives a value of undefined. So we have the variable, it has been declared, but we have not initialized the value. So the next thing again, or in this case, you can see that the variable was declared first before we tried to use it. So let me try to use the variable before declaring the value, before declaring the variable. So if I run this, it will give us undefined. So what's happening here is something called variable hoisting. So in JavaScript, a variable will get hoisted. The same way you will hoist a flag, that's basically raising it to the top. So it will get hoisted. We are going to cover hoisting later on. So just keep that in mind. So if I undo this, and now let's look at reference error. Now a reference error, we said trying to call a variable that does not exist. So if I try to call y, alert y, and run this, you'll see we get this error. So we get an exception, a reference error. So if you try to access a variable that does not exist, a variable that has not been defined yet, you'll get a reference error. And now I want to use let. So let me see if I use let x and then alert x, what will happen? So if I run this, it will give us a syntax error. Okay, this is the same thing we experienced before. So let me use a different variable. Let me use z and then alert z, and then we run this, it will give us undefined. So you remember in the other video, in the other example, just before this, we were able to put alert before let, and we got a value of undefined. What happens if we try to do the same with a variable that has been declared with let? So if you try to run this, it will give you a, oh, okay, let me use a different variable. First of all, let me say a. So alert a, and then we try to declare a with let before we try to call it. So if I run this, it gives us a reference error. Unlike for var, if you were to use var here, this variable would get hoisted to the top. So if you don't want your variables to get hoisted, you will use the let keyword. So to hoist, basically, we'll define this variable at the top of the code. All variables that are declared with var or without the var keyword, they are always elevated to the top. So that's what's happening here. If you use let, it will not be elevated to the top. We are going to cover variable hoisting later on. So in this video, we've taken a look at undefined and reference error, whereby undefined basically means the variable is there, yes, it has been defined, but it has not been given an initialization, it has not been given a value. And then for reference error, that's a variable that does not exist, and if you try to call it, it cannot be found in the system, in the memory. So let's continue in the next video. Hey, and welcome back. What does it mean if a variable has a value of null? Well, in JavaScript, null is treated just like 0. So if I was doing some kind of arithmetic and I was using null, it would behave just as 0. So let's see this and believe it here in Scratchpad. So if I come here, let me delete all of this. So let's say var, let's call variable var tax is equals to null, and then alert. Let's do some kind of arithmetic. So let's say null times 10,000, and then we run this. You'll see it's equal to 0 because it's treated as 0. So we can also say null plus 10,000. If we run this, it's 10,000. So null is treated as 0. Let's continue in the next video, and in the next video we'll start looking at variable hoisting. See you then. Hey, and welcome back. So in the last video we say that we are going to look at variable hoisting, but before that we need to look at variable scoping. So scoping basically defines how a variable is usable. Is it a local variable or a global variable? A global variable is accessible in the entire document, any part of the document that you go to, and by document I mean a .js file that has lots of JavaScript code. So that's what I'm calling and referring to a document in this case. So you may find that a document may have functions and may also have something like an if block. So in this case, this is an if block. So this if block has its scope. So the scope of this if block ends. It ends where this final closing bracket ends. So in a normal programming, in other programming languages, if this was the case, this variable would be what is called a local variable. It would only be accessible within this block. That makes it a local variable. But if it was defined outside of this block and outside of any function, it would be a global variable that is accessible by any other function or by any other if block or by any other thing that wants to use that variable. As long as it is not defined within a function or within an if block or any other kind of block like else block, it is a global variable. So JavaScript, as we know, is a very loose language, and if you use the var keyword, this variable will be accessible from outside of this block. So the scope of this, to some extent, is a global variable. If this was something like Java and this was a class, this variable would not be accessible from outside of this block. In Java, we have public variables, protected variables, and private variables. So unless it was declared as a public variable, it would not be accessible from outside of this block. So I hope you do understand what scoping is, and in the next video, let's look at an example of this. Let's look at an example of this and see how variables are accessible outside of the block. Hey, and welcome back. So in this video, we want to look at an example that shows us something about variable scoping. So if I come here and I open Scratchpad, and on Windows you can do that by Shift F4. So I'll just come here and copy this code. I want to use this for our example. And now, you know, in our examples we've been using alert and not console log. So in this case, this is a local variable within this if block, and yet we can still access it from outside here. So that is when we use the var keyword. It's very important to note this. If you use the var keyword, this variable is accessible from outside of this block. So if I run this, you'll see it gives us 5. But then you know that we also have without the var keyword, which is not advisable to be used at any point. So even with this, if I run this, it will still give us 5. And now we also have the let, and with let, if you declare a variable using let, this will not be accessible from outside of the block. So that's one reason to use the let keyword. So if you use let, it will not be accessible from outside, and since we have used x as a variable, we cannot use it for the let again, and we saw this in previous videos. So I will change that to y, and that will also become y. Then we run this and you will see the reference error. This is something that we spoke about, and we say that if you see the reference error, this basically means that the variable has not been declared. So if you use the let, you can see this is a true local variable if you use the let to declare a variable. So we also have const. So a const is also new in ECMA 2015, and if you use const, which simply just means that this variable to some extent is immutable, but it is not a constant like in other programming languages. It is not a constant with the same principles and with the same nature of behavior. This is a way for JavaScript to try and copy a similar thing, but it is not exactly the same as a constant in other programming languages. So for this one also, I will not use y, it will bring issues, but I can use z. So if I use this z and I try to run this, you will see it also gives us a reference error. So you can use the const for something that is not going to be mutable. Okay, so in this video we've seen examples of variable scoping. So as we saw in other videos, you saw that if you take this and you put it up here, there are cases if you use the var keyword, it will show you undefined. So you can do an example with those and see how it is. Just take the variable and put it up here for the for the var keyword. If you use the var keyword, you can try and put this up here and see what will happen. Think of that as your assignment and as a way for you to practice this for yourself. So I will see you in the next video, and in the next video we're going to look at variable hoisting. Hey and welcome. So in this video we are going to look at hoisting, variable hoisting. So the exact meaning of to hoist is to lift or to raise to the top, the same way you hoist a flag. So in the same sense, variable hoisting means that a variable will be raised to the top once it is declared. If you declare a variable down here and you call that variable up here, the variable will be hoisted, meaning that if you declare x down here and you try to use x up here, this variable is always hoisted to the top. Although if you try to call this variable and use it and try to get its value, the value will be undefined, and we did see this when we were looking at undefined and reference error. So a variable is always hoisted to the top, and it's very important to note that only variables that are declared with the var keyword are hoisted to the top. If you declare a variable with the let keyword, it will not get hoisted. And if it is also a const, it will not get hoisted. We'll look at const later on. Functions are also hoisted. So if you declare a function, it will also be hoisted to the top. And this is similar to a bunch of C-based programming languages. Even PHP, you can declare a function later on and call it before even the function declaration. As long as the function is there, it will work just fine. So in JavaScript, function hoisting only works for named functions. So a named function is a function that has a name. So it has to be defined or declared as function and then the name of the function. And then whatever you want to do with the function will be in there. So it has to be a named function. There is no way to hoist anonymous functions and function expressions. So a function expression is, for example, if you declare a function and you want to store it in a variable, you can say var declare is equals to a function in here. So in the next example, in the next video, we're going to look at variable hoisting and function hoisting in one simple example. So I'll see you in that next video. Hi and welcome back. So if I come here to Firefox and then open Scratchpad, I already have this typed out here. So in this case, you are seeing that I'm calling X and X has been declared down here. So if I run this, it will give me X is undefined. And this is an example you are familiar with because you saw the same thing when we were looking at undefined and reference errors in JavaScript. So if I run this, okay, this is because I already did run this with X up there. So let me change, let me call Y and then run this. Okay, I also did run Y. So let's say I do Z and I I change this to Z, and then I run. Let me close that, and then I run. You'll see it gives us undefined. So the reason the first time I did X and Z, they showed the values of 5 and 10 is because that is the second time I was running this code. You know that by the second time I'm running the code, these variables are already stored in the memory of the browser. So even if I run this a second time, and right now if I run this a second time, it will give me the value of Z as 5, because by now the value of Z is already stored in the browser. So if I run it, let me first of all close this undefined, and if I run this, it will give us the value of Z is equals to 5. And this is because the value of Z, by the second time I'm running this code, the value of Z is a variable that is already stored within the memory of the browser. So keep that in mind. Okay, so we say that functions are also hoisted. So this is a simple function, and I have it commented out. This is a simple function that adds 3 and 4. So in the next video, let's look at how this function will get hoisted to the top. I will see you in that next video. Hi, and welcome back. So the first thing I want to do is comment this out and uncomment this. We'll take a look at functions later on, but for now, you just need to know I have declared a function called add, and the only thing that this function does is it adds these two numbers. Okay, so let's say maybe that's 10 and that's 15. So unlike with variables, if you call a variable that is declared below, it will tell you that that variable is undefined. But let's see what happens if we call this function before its declaration. So this is the declaration. Let's call the function here. So this is how to call a function, a named function in JavaScript. So I will run this and it will give us the result of 10 plus 15. So if I run this, it gives us 25. So that is the first part of this. Now I want to do an experiment. Let's say in a function you can also have variables in here that will be added in here. So we'll take a look at functions later on, but I just want to see what's going to happen. Let's say I call this num1 and this num2, and then I come here and I say use num1 and use num2, and then let me just copy these two because I don't want to type. Then I will paste them in there. I will change that with a plus. So basically what this function does is it adds two numbers, and the two numbers it adds is num1 and num2. So, and it alerts the result of num1 plus num2, and we have declared num1 and num2 outside of this function. So let's see what happens if we try to run this, because this is a declaration of these variables way before they're being used. So they're being used up here. Let's see, because we know that this should become undefined and this should also become undefined. So let's see if this is going to give us undefined as well. So if I run this, it gives us not a number. So what not a number means is basically it tried to add a value of undefined and a value of undefined. So in the other video, we saw that once we ran this for the first time, these variables got stored in the memory. So let's see if we run it again that will be true of this. And it still gives us not a number. So let's say that I take these two and I put them in here and I try to run it. It still gives us not a number. What if we take this and we declare them before we use them? So function add num1, num2, and then if we run, it gives us 15. So you see, the thing is, it's always good to declare the variables before you use them. So declare the variables before you use them. So the only thing about hoisting is that it will help prevent any crashes in your system. If you're using JavaScript for building something, the only useful value of hoisting is that it will prevent your application from crashing altogether. But there's no other benefit to it. So always make sure you declare the variables first and then you use the variable in all instances. If it is going to be a global variable that you're going to use somewhere else, just put them at the top. And you can also declare your variables in one line, just like that. So always declare your variables at the very top before you use them. If it is a block-based kind of variable, you want to use it within a function, declare it within that function and use it then. So I hope you've understood that variable hosting is there, but it's always best to declare your variables before you call them. So I will see you in the next video. So you saw that when I ran this, it gave us not a number. So you can just take this and put it back inside the function. And if I run this, it should give us 15. So I'll see you in the next video. Hi and welcome back. In this video, let's look at constants, that is const, the const keyword. Now the const keyword can be used to create a read-only named constant. So this is from Mdn, from the Mozilla Developer Network, and it says the const declaration creates a read-only reference to a value. This doesn't mean the value it holds is immutable. It just means that the variable identifier cannot be reassigned. I will read that again. It says that const declaration creates a read-only reference to a value. It doesn't mean the value it holds is immutable. It just means the variable identifier cannot be reassigned. So what does this mean? This means that the identifier of the const cannot be redeclared and it cannot be reassigned. Let me open Scratchpad and we're going to see exactly what this means. Shift F4 on Windows should bring up Scratchpad. There we go. So if I declare const VAT, value added tax, equals 16. So this is the identifier. So this means that we cannot redeclare another const we cannot redeclare another constant with the same name and change it. We cannot in the same scope. One of the most important things to understand about this const is that most of these rules are based on blocks. So just hold on. In a few videos or just in a while, I will look at examples that show something about the blocks to show that most of the rules mostly apply in the block level. So just like let, you remember the let keyword for variable declarations, it is a block level variable, meaning that it is mostly affected within the block. Okay, now some things about the const is that the identifier syntax, or rather the naming convention for the identifier, this is the identifier. It follows the same rules, the same syntax, and the same regulations for variables. And if you go back, you will see the rules that I told you about when naming identifiers for variables. It cannot begin with a number, so it can only begin with a letter, an underscore, or the $sign. You can go back to the videos where we talked about variables. You will see all the rules for naming a variable. And then another thing, when you declare a constant, it must have an initialization. So, you know, with a variable, you can just say var vat and you will initialize it later. But in this case, you have to give it an initial value. Delete that and delete this one as well. So that's it for this video. We've just had a brief introduction of constants, the const in JavaScript, and we have talked about the naming convention for the identifier, some of the few rules for the const, and that this value is not necessarily immutable. And it's also important to note that const is a block level variable, and that means it's mostly affected and affects the block within which it is. And we're going to see that in the next step. So I'm seeing you in the next video. See you then. Hi, and welcome back. So in the last video, we started looking at constants, and the last thing I said was that const is a block scope variable. So in this video, I want to introduce some blocks, some kind of a block, so that we can see exactly what the block scope behavior of const is in JavaScript. In the last videos, we haven't really talked much about the block scoping, especially with the let variable keyword. But after we look at this video, you're going to understand exactly what I mean. So I want to introduce some kind of a block here, and I don't want to introduce a function, so I'll just do if. I'll just do an if block. So let's say true. If true, do the following statement. So I will take this and put it within this block, and this is going to help us. This is going to help us explain a lot of things. The reason I don't want to use Scratchpad without any kind of block is because of some issues we experienced with you in the last videos, whereby once I declare a variable and I run it, the variable is still stored in the browser memory. So if I introduce a block, it will help us curb such kind of issues. So here we have an if block. So basically, we are going to look at these kinds of statements in future. Don't worry much about this. I'm just using this so that I can explain the const. But we are going to look at things like if else in upcoming videos. If not in upcoming videos, in upcoming courses. So just bear with me. So basically what this does is, if true, do whatever is inside this block. So the only reason I'm using the if is so that I can introduce a block. So that's a full block there. And we know that const, as I said in the last video, const is a block level variable. And one thing I didn't say in the last video is once you declare a variable, once you declare a constant, const, with an identifier, you cannot use the same identifier to declare another variable. So for example, let me say I try to say var VAT. If I try to do this, this will give me an error. So if I try and run this, you see it says the declaration of const VAT, and that is the same for let. Even if I change the name of this to VAT2 and VAT2, so, and I try to run this, it will still give us the same error, the declaration of const VAT2. So you cannot use the same identifier that you're using for a constant to declare another variable, and you can also not use the same identifier to declare a function. So if I say function VAT2, just that, and let me remove this, and if I try to run, okay, let me put this one here, and if I try to run this, it also missing before statement. Where is that? Okay, this is function, not fuck node, whatever that is. So if I run this, you see redeclaration of const VAT. So that basically means you cannot use the same identifier for a function, a variable within the same scope if you've already used the same identifier for a constant. So I hope you've understood the identifier thing, where you cannot use the same identifier for the same constant and also for a variable. So if I delete this, and then let me remove this va2 thing. Here we said, let me delete all of this. So maybe you might be thinking, oh, let me change the value of my const VAT. Maybe VAT has changed, so you want to change it, and you just come here and declare. So if I run this, you'll see the declaration of const is not allowed. But one thing about const that I have already told you is that it is a block level thing. So if I create another if and redeclare const VAT, there won't be any issues, and we're going to see an exact example of that in the next video. So in this video, just go through everything I've spoken about using the same identifier for variables and functions. So I'll see you in the next video. Hi and welcome back. So you've seen that I've been naming my constant with capital letters. Well, you can use small letters or capital letters, but in most programming languages, you'll find that most constants, they are always defined with a capital letter. So I'm just trying to do the same thing, just following those conventions. I suggest you use capital letters. At least it will help you know just by looking at your own code that that is a constant. So in the last video, I said that we are going to see and do some experiments just to see what happens if I copy this and I just do that. So first let me remove this, and then of course remove this, remove this. Now we have const VAT defined here, and here I want it to be 160. So you can see these are two different blocks. So if I say alert VAT, so that it can show us the value of the VAT which is here and the value of the VAT which is here. So I'll just copy the same thing and put it here. So this statement will run. The if statement will run because this statement is true. That's why I used true. You know what? I can just do another copy as well and copy there, and let's make this one 1600. I'm just using this as an example. So if I run this, I should be able to see if it is going to give us all these examples, all these values of VATs, because this is a different block, that's a different block, and that's another block. So if I run this and I come here, you see the first one is 16. If I click OK, the second one of 160 is also there, then 1600 is also there. So what that shows us is that this is a block level thing. You can see I can declare a constant in one block and redeclare the same constant in another block with a different value, and there won't be any issues. So that's exactly what block level means. So in this video, we've seen that const is truly a block level variable. We declared it in one block and then redeclared it in another block and yet in another block with different values, and all the values were brought back with the actual values within those specific blocks. So in the next video, let's look at something else, if there'll be anything else about constants. So I will see you in the next video. Hi and welcome back. So I've also come across this about objects, and I want to talk about this one. In one of the last videos, I said that when you're declaring a const, you cannot use the same identifier for another variable within the same block. And it's the same thing for an object name. You cannot declare an object name. We're going to look at objects and functions later on. So it says that object attributes are not protected. So the following statement is executed without problems. Object attributes, these are the object attributes. This is the object attribute, the key and the value pairs. So let me copy this and just bring it to Scratchpad. I will remove these two and paste in what I have within this block. So const, if I declare an object as a constant and I give it the name, my object, and it has a key and a value. If I point to whatever is here, I can give it a different value, which we know should not be true for an object. We cannot change the value. We cannot change that value directly like this. So this would be like redeclaring this. So basically what that statement meant was that the const does not protect the attributes. So let's say I have this, my object. Let's say maybe it's a graduation list, right? And you have a name. So name, and then the name is Ricky W. And then I want to change my object dot name. So I want to change it to something like Victor W, right? And then I want to alert the value. We'll look at objects later on. So if you don't understand about these object things, don't worry, I'm just using it as an example. So if I come here and alert the value of the object and I run this, it tells us that the value for that is Victor W, even though our variable, our constant, was declared with this one. So I just thought that's something I should tell you about, even though we are going to look at objects later on. And once you understand more about objects, you'll be able to understand where you can use it. Somewhere I can see this useful is, let's say this is a graduation list. Maybe you don't want people, or you don't want this list to be tampered with. Maybe that's a scenario where you can use the const. So that's it for this video. I will see you next time. See you in the next video. Hi and welcome back. So we're going to start looking at data types in JavaScript. So as you already know, JavaScript is a loosely typed language. That means that it is not as strict as certain statically typed languages. So when it comes to data types, most of the work will actually be following you to make sure that the data that gets into the system, the data that you get from the user, is the right kind of data. So all of that will be following you as a programmer. What are the data types that we have in JavaScript? The primitive data types that we have in JavaScript. So the primitive or the primary data types that we have in JavaScript are number. So a number that can be 1, 1.2, negative 10. So this is a primitive data type, number, any kind of number. That is the first primitive type we have in JavaScript. And then we also have strings. So strings are characters. Maybe you want to put a word in there. You want to say, hi, how are you? That can be represented by a string. So we do have numbers, then we have strings, and then we have the Boolean type. Now the Boolean, this represents two values, true or false. So this is used to represent whether a value is true or false. You'll see things related to the Boolean type when we start looking at conditional statements. Things like if x is less than y, then do whatever is inside the curly braces. You'll see about the Boolean type come into play in this kind of statements. So the Boolean type has two values only. It can either be true or it can be false. And then we have the null. Now basically the null, this is an object that has no type and has no value. So you can say something is null when it doesn't have a type and it doesn't have a value. And then we also have undefined. So undefined basically means we know that it is there. We know that it is there. Let's say, for instance, it's a variable. It is there, yes, but we haven't given it a value. It doesn't have a value. So null is for objects. You'll see when we start looking at objects, null is for objects, whereas undefined can be for variables, properties, methods. So the primary data types that we have in JavaScript, we have said are number, string, Boolean, null, undefined, and symbol. So symbol, this is new in ECMAScript 2015. So this one is the data type whereby the instances are unique and immutable. So you'll take a look at this when we get to this part. So we'll take a look at these symbols when we get to the part about new things in ECMAScript. Now, other than the primary data types, we also have objects. And an object, these are named key value pairs, data containers that you create. So you can maybe create a person object which will store maybe a name, and then on this side, so an object is a key value pairs of data items that you can create yourself, maybe to store certain kinds of data. So you will look at objects later on. So in this video, we've taken a look at some of the data types that we have in JavaScript, and we've said that we have the primitive data types, which include number, string, Boolean, null, undefined, and symbol. And then we can also have objects. So let's continue in the next video. Hi, and welcome back. So JavaScript is dynamically typed. So this means that you can change the type of a variable in your code. An example is this. We have this variable. We have declared this variable clearly as a string. Here you can see that this is a string. So note that when you have strings, you must always enclose them in the quotation marks. This one. You can use the double quotes or the single quotes. And this is true of many C-based programming languages. So going back to data typing, dynamic typing, we have this variable up here as a string. Then later on, you can declare the same variable, or rather you can give the same variable. You don't have to redeclare it. You can just give the same variable a different value. So if I come down and I give it a different value, and you can see in this case now it's a number. And now that it is a number, we can call it, and the last variable it will give us will be a number and not the string. And this is not going to give you any error in JavaScript. In other strictly typed programming languages, this would give you an error if you try to give this variable, which was clearly defined up here as a string, and then you come down here and you give it a value which is a number. That would give you an error in other programming languages, but in JavaScript, this is not going to give you any errors or any warnings. So if I come here on, let me just go here and open Scratchpad on your computer. And to open Scratchpad, it's Shift plus F4 on your keyboard. Once you've opened Mozilla, once you've opened Firefox. So here I have this variable declared, variable question, and I have given it an instance of a string. So note that strings always have this double quotation marks. So if I come down here, so in the past, before I go on, I have gotten back results using alert. So if I alert this, it will bring an alert box for me. But on Scratchpad, you can also just display a value right there. So if I say question, this will give me the value of question. So instead of alerting it and having to go to the browser to see the result, I can just come here where var question has been declared, and then I call question down here if I want to find the value of question. So if I display that, it will give me the value of question within this comment. So we have declared a variable called question, and then we have given it a value as a string. So if I come down here, let me just copy this one, Control C. So right now this variable is like a string. If I come down here and I change the value of this to question 3, and then I come and call question, I want to know the value of question, and then I click on display, it will tell us the value of this variable right now is 3. So note that this is the same thing. If I was doing an alert, I would just enclose it. I would enclose this question within the alert so that it can give me a value in the results. So from now on, I will be doing this. I will be mixing between the two. I'll maybe do a display, maybe do an alert, but I wanted you to get comfortable with the alert before I moved on to the display. So this is only true here on Scratchpad. If you're using anything else, you have to use another way to display your results. So for example, if I say 2 plus 2, I can just come here and click display, and it will give me the result within these comments. So that's why from now on, I will be showing my results using display, and once in a while maybe with the alert as well, until you get to a point where we'll start using JavaScript within HTML. So in this video, we have seen that JS is dynamically typed. That means you can change the value of a variable to another. If this was maybe a number, down here you can also give question, this variable question, you can give it a different data type. Like in this case, we took it from a string, and then we also gave it a value of a number. And the JavaScript interpreter did not complain at all. This is not true for other programming languages which are strictly typed. So that's it for this video. I'll see you in the next video. If you have any questions, let me know. Hi and welcome back. It's Ricky, and in this video, let's see what happens if we have a number, a string, and the plus operator. So what we want to see in this video is what happens if I do add a string to a number. So what will happen when you add, in JavaScript, when you add a number and a string, the number will get converted to a string. So like in this case, this is a string. You can see this is a string because it is enclosed with these double quotations. You can also use the single quotations. So if we add these two, this is a number and this is a string. If you add them, you're going to get case 39. Also, if you add this is a string because it has the double quotation, and this is a number. So if you add this and this, you will get, if you add these two, you're going to get 100, 100. You're going to get that result. So what we have here is what is called concatenation. This is joining. So the plus operator is going to join the two. It's going to join the string and it's going to join the number. And that's what we get. So that's called concatenation, the plus operator. If it has to operate between a string and a number, it will join the two, and that's called concatenation. So if I come back to the browser, I have two variables, variable y and variable x. Variable y has been declared as a string. So this one is a string, and this one is a number. Now if I come down here and I add the two, x plus y, and then I display the result, is going to give us a concatenation, that is joining the two. If I remove this so that it becomes a number, and then I do the addition again, display, you'll see now it gives us a result of 200. If the first one is a string, now let me use the single quotation this time round. Let's say number 2, and then we try to add x and y. This is clearly a string and this is a number. If I try to add the 2 and I display, you can see it gives us a concatenation of 102. So let me add some space there, then come down there, click display, and you can see the result it gives us is 100 number 2. So is that the same? What if we changed? What if we change this one to multiplication? Or even, what's going to happen? So let me come back here. So this is not true for other operators. So in other operators, if you have a string and a number, like in this case, this is a number that's a string, it's going to treat this as a number and it's going to give you back a result of the subtraction of the two. And the same is here of a multiplication, even a division, any other operator. If you're using any of those arithmetic operators, we have multiplication, we have division, we have the modulus. Which one else do we have? Whichever else you can think of, the subtraction. If you use those with this, it's going to give you a result of the two, treating both as a number. So for instance, in this one, let me just clear out all of this. In this one, we have x minus y. So this one, what's going to give us is, this is going to give us not a number. So if I display this one, it's going to give us not a number because it tried to treat this as a number, but it was not a number. So that's what happened. But if I change this, it will actually try to convert whatever is in here to a number. So if I come here and I say 200, so it will convert this into a number. Although the entire thing is a string, when it's doing the
calculation, it's going to convert the string value to a number. So let me come here and display, and if I display, it gives us negative 100, that is 100 minus 200. If we make it a multiplication, we're going to get the same result of 200 times 100. If you make it a division, and you display the result, it's going to give you 0.5. If you make it a modulus basically gives you the remainder. If I display this, the modulus is actually 100. Let's do a different example. If you say y divide by x, y modulus of x, let me remove all of this. So y modulus of x, if we display this one, it will give us 0, because y, 200 divided by 100, 100 goes into 200 twice, and the remainder is 0. If this was something like 3, display, so the modulus is 2, because 3 will go here 66, I think it will go there 66 times, and there will be a remainder of 2. 3 times 6, 18, 3 times 6, 18, 198. So there will be a remainder of 2. So the modulus simply gives you a remainder. So in this video, we have seen that a number plus a string will become a concatenation. However, a number and a string with any other number, the string will be converted. The interpreter will try to convert the string into a number so that it can do the operation. And that is why this was converted to a number and the result we got back was 90. This was converted to a number and the result we got back was 500. And if whatever is within the string cannot be converted to a number, it will return to us not a number. So if you have any questions, feel very free to let me know. I will see you in the next video.
Hi there and welcome back. So in the last video we did something about the string, number and the plus operator. So in this video, let's see how you can convert a string to a number in your code. So if a number is being held in memory as a string, as we saw with an example like this, 110 quotation, that means it is being held as a string. You can convert it to a number before you use it. So there are different ways of converting a string to a number. And one of the ways we have is using the parseInt function. We also have the parseFloat function. So in the parseInt, you'll put the number there, the string there. This is a string. And then this is what is called a radix. Now the radix, this is the base of the number. So we're going to look at this in coming videos. So I don't want to talk much about this because we're going to look at this in detail. We're also going to look at this in detail. And in this video, let me just show you an example using this one. The unary plus is whereby you put the plus before the string and then you do your operation, and the other number, which is also a string, you put a plus before it, and that will convert the number which is here into, it will convert the string which is here and the string which is here into a number. So in this video, let's do an example with plus. And as I said, in the coming videos, we're going to look at these two extensively, the parseInt and the parseFloat. So if I come back to Scratchpad, let me delete all of this, actually undo that, and only delete these ones. I can also make this into a string. So these both are strings. You can use the double quotes or the single quotes. Let me say I do y plus x. Y plus x, if I display, it will give us a concatenation. It will join this and this. But now, if I come here and I say, let me enclose this in a bracket, and the bracket is used as a good way to just separate things. So I can say that plus, and then that one also enclosed in a bracket.
and then I add the plus operator. So if I add the plus operator in front of this number, it's going to convert this into a number, and it's going to convert this into a number, and the result we're going to get is going to be different from this one, which was a concatenation. So if I display, it will have changed this into a number, change that into a number, and it will give us the result of 200 plus 3. So also, if I say plus 100, let me convert this into a string, and then plus, let me put this side into a bracket for easy reading, plus 200. So it will convert this into a number, and we'll convert this into a number, and then it will give us the result of these two. So if I display, okay. So first of all, let me remove all of this because it's confusing my system. And then I can display that, and it will give us the result of converting this into 100 and converting that into 200 as 300. So in this video, we have said that you can convert a string to a number before you use it. And the methods we've said you can use are parseInt. This is a function that will convert the string you put in there into a number using the radix you define. We're going to talk about this in the next video. And then you can also use the parseFloat. Now the parseFloat is also a function that will convert the number into a floating number. This one converts it to an integer, this one converts it to a float. This one will just convert it into whatever you have. If you have maybe 11.11, then you add the plus, and then this side you also add 11, then that is converted into a number. It will take it the way it is and add them. This one will return a float, and this one will return an integer. So in the next video, let's look at the parseInt. If you have any questions, feel very free to let me know. I'll see you in the next video.
Hey, and welcome back. And welcome to the parseInt video. So in the last video, we started looking at how you can convert a string to a number. So if you have something like this being held in the memory, this is a string, but you want to convert it so that you can use it as a number. So in this video, let's see how you can do the same using the parseInt function in JavaScript. Now, the parseInt will pass a string, and it will return an integer based on the radix you define. So what is a radix? A radix is the base of the number. So we have different radices. Now the radices that we have, or rather the radices that we mostly use, is base 10. Base 10, which is a decimal numeral system. So you don't really have to worry much about this because it's just something you need to know, and that's enough. So the decimal numbers that we have are what we use. So the radix basically means the unique amount of different digits that can be used to represent numbers in that system. So our decimal numeral system that we mostly use has 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 0. So if you count this, they amount to 10, and that is why we have base 10, our decimal system. You may also have heard about the binary, and the binary has only two possible numbers, 0 and 1. You may also have heard of the octal system. The octal has 8 possible numbers. So it will start from
let's put 0 here. So it can start from 0 all the way up to 7. That is the octal. You may also have heard of the hexadecimal system. Hexadecimal, which has 16 possible digits that can be used to represent a number in that numerical system. So in the hexadecimal system, hex, let's just call it hex, you can have 0 up to 9. And then from 9, you will use A up to F, so that they can be 16. So let's just say A, what do we have there? A, B, C, D, E, F. So you'll have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A will be 10, that will be 11, 12, 13, 14, 15. Then if you add 0, there will be 16 possible digits, which gives you the hexadecimal. So the radix is the unique digits that can be used in the number system to represent any number in the system. In our decimal system, we know that if you want to represent a billion, you can only use numbers within 0 to 9. So that is what the radix is all about. So if you want to convert a number, you want to convert a string to a number using the parseInt, you'll put the string in there and then you put the radix. And now the radix is a number from 2, can be a number from 2 to 36. And we've explained what a radix is. In most cases, the radix we use is 10. That's our normal numeral system. So for the other radices, if a number goes beyond 10, all the other parts of the number will be listed using the alphabet. So from A to whatever, like we've seen for hexadecimal, it goes all the way up to F. If you want to represent a number with a radius of 11, the next number in the series will be A. So 11 will be A. If you want to represent a number with 12, the next number, so as long as it reaches 9, you start to use the alphabet numbers. So here are some examples. F23, we are converting this into a hexadecimal number that has a radius of 16. Let's continue from here in the next video so that we can continue more and learn more about this parseInt and how we can use it. So I'll see you in the next video. Hi and welcome back. This is where we ended the last video, and in this video let's continue on with parseInt, how you can convert a number from a string to an integer. So we've said that in the parseInt, the first thing that you have here is a string, and then you specify the radius. So you can see this will be converted to a hexadecimal number. And it's very important to note that if you don't define this number, the default in most cases, in most systems, in most interpreters is 10. But the general advice is that you should always define the number there. Even if it's 10, you should always define it to avoid any misbehaviors depending on the system that your program is running on, or rather your application is running on. So you should always define the radix. So in this case, this one will be converted to hexadecimal number, and then this one will be converted. This will be converted to a decimal number. So this one also will be converted to octal number. So you must note that whatever number this is, if you're dealing with a octal number or a binary number or any other radius number, the number, whatever is in there, must also match the digits which are here. For example, if this was 1, 8, and you defined this to be converted to this octal number, what would happen is it would convert the first number and then ignore this other one, because this one is not part of the radices which are in an octal number, which start from 0 to 7. So let's see this as example so that we can understand exactly what's going on. So if I come back to Scratchpad, I'll remove everything, pass int. Let's say we have a number stored as 23, and we can convert it to a decimal of 10. So if I display this, it will give us the number of 23. If I copy that, Control C, I bring it there, and then if I try, so you should note that if this is not able to convert the string into a number, then it will give you what's called not a number. So if it tries to convert this and it is not able to convert it, it will give you not a number. So if I try to display this, it will give us not a number. And the same thing is true for other kinds of radices. So let's say we have 0, 3, right? And we want to convert this as a binary digit. We know that numbers in a binary number can only have 2 digits, which are 0 or 1. So in this case, 3 is not part of the possible numbers in a binary number. So if I try to convert this, it will only convert it up to the point that it can convert it and ignore the rest. And that is the same. That is the same for any of this. If I take this and we know 23, that's okay. Then maybe 2, 3, 5. We put an A in there. It will only convert this up to the point that it can, and then it will ignore the rest. So 23 is what will be returned to us, and everything else that cannot be converted will be ignored. So if I display that, it only returns up to the point that it can convert that number. You put that there, then you convert it to 16 to a hexadecimal number. You'll see it will return to us an hexadecimal number. Display that, it will return to us 291. So 291 is a decimal number that is equivalent to hexadecimal number. So you must always note that the numbers you put here, they must also have the same digits that will be available in here. So like if you say A, B, C, D, E, F, this will be converted to a hexadecimal digit. So let's just see the result of this. If I display, the result is this one. This is the same decimal number that is equivalent to this hexadecimal number. So you can, if you're not understanding this, just go to Mdn and read more about this. I'll provide the link to the section on the pass int. Just go and read more, because if you read more about it, you'll understand it better. But it's basically, this is how it works. The numbers which are here must be available within that. So if I would have added G here, we know that G is not available in the hexadecimal numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A up to F. It doesn't reach up to G. So this is going to get converted up to that point, and then it's going to ignore the rest. So, and then if we display this, it will give us the result of 171, which is just this 2. If I remove everything else, and then I display the result of that, you see it's 171. So it just does up to the point that it can. If it encounters something that is not part of that radix, then it will ignore the rest. So let's continue in the next video and see what else we have in passInt.
Hi and welcome back. So what I said in the last video is that there are certain cases where passInt is not able to convert the string into a number, and if it tries to convert something into a number that it cannot convert to a number, it will return not
a number. So for example, let's say you have a string A, B, C, and you want to convert this into a decimal number. Of course, there is no digit within the decimal numbers that has any of this. So there will be no way for this to get converted to a decimal number. So this will return not a number. And then you see this int, we are converting this into an octal number, and we know that an octal number only has digits from 0 to 7. It doesn't have 8 and it doesn't have 9. So this will not be convertible to an octal number, and that will return not a number. And then this one, trying to convert this one into a binary number, we know a binary number only has 0 and 1. Only these two. And we're trying to convert these ones into a binary number. These are not available in the binary digits. So these ones will give you not a number. So let's go to the browser and just see some of this in examples. So if I come back to Scratchpad, let me just delete everything there. Then let's start with this one and convert this one into 2. We know that these ones are not part of 0 or 1. We know that 0 and 1 are the only acceptable numbers that can be converted into binary. So if we try to convert this one and display, it returns not a number. And then let's say we take this one into 1 and 9, 183, and we try to convert this into an octal number. So an octal number only has from 0 up to 7. 8 is not there. So that means it will convert up to the point that it can convert something to an octal number. In this case, 1. So if we display this one, it will only return 1 because it converted 1 into an octal number and then was not able to convert the rest. So if I remove this one, and now we only have 83, it will not be able to convert 8, and it will stop there, and it will just give us back not a number. So if I display that, it gives us not a number. If I also come here, let's just use something else like A, B, C, D, E, and then we try to convert this into an octal number. And then we display, it will return not a number. There are certain cases where you may not have that. It may be undefined or missing. So in this case, if the number which is here is like this and we try to display this number, it will give us back not a number. And if we put 1, 2, 3 and then we try to display this, let me give you a good example here of 14, right? If I start this number 1, 4 and I don't have a radius and I display this, so the int, if I convert 14 into a number and display it, remove all of that, if I display this, it will give us 14. So if I convert this, it will give us 14. So let's come back here and see certain rules for how this might behave if we don't have a radix. So I don't want this video to be long, and therefore in the next video, let's come back here and see what will happen if the radix is 0, or the radix is undefined, or the radix is missing. So I'll see you in the next video. Hey! So this is where we stopped in the last video, where we saw certain cases of not a number in the int function. So in this video, let's see what happens if we have a situation whereby the radix is 0, the radix is undefined or missing. Now, if the radix is 0, undefined or missing, number 1, if the string begins with 0 and a small x, or 0 and a capital X, the radix will be considered as 16. So maybe if you have something like 0x192, this will automatically make the radix 16. 0x, x stands for hexadecimal. And number 2, if the string begins with 0, the radix will be considered 8 or 10, and this will depend on the implementation of the browser engine. So there are certain browsers that will consider it 8, others will consider it 10 if it begins with 0, and that entirely depends on the browser. But from ES5, ECMAScript 5 implementations, the default will be 10. So even if the number begins with 0, the default will be 10. And then number 3, if a string begins with any other number, any other value, the radix is always 10. That means if it does not begin with 0x or small x, or does not begin with a 0, it will always be considered 10. So if it begins with A, any of the letters from A to Z, or any of the numbers from 1 to 9, in this case, it will always be, the radix will always be considered to be 10. So if I come back here, and let's start with the first one, where we say that if the radix begins with 0x, then the number is considered, the radix here will be considered as 16. So if I come here and I display, you see this is giving us 20. That's because this was given a radix automatically of 16. If we didn't have the 0x and we try to display this, it will give us 14. If you don't put a radix in there and the number begins with 0x, it will be considered as a radix of 16. So you should always put the radix in there. And then the next one we said was that if a number begins with 0, let's say 023. Let's see if we display this one, it returns 23. So you can see in this implementation, in this particular implementation of my browser, we are automatically returned 23. And this means that the radix that is being used is 10. However, in other browsers, it could be different. But in this particular browser that I'm using, the Firefox engine is using 10 as a default. And then if this one starts with any other number, let's say it starts with 9, that, and we display, it will convert this number based on the radix of 10. So I hope you've understood this. I mean, there is no easy example to show this. You only have to understand them the way they are. If a string begins with 0 with a small x, so this is hexadecimal. We're later on going to see something like 0 and O, whereby O stands for octal. So we're going to see that when you look at number literals. That is the next section from this, when we start looking at literals. So in the past few videos, we have looked at the parseInt function and how you can use it to convert your numbers. You can convert any number, you can convert any string into a number. So if this was our number and we use that and we display, that's what happens. If that was radix of 16, you see it gives us a different number. So always display the radix, even though in certain modern browsers it will be assumed to be 10. As long as the number doesn't begin with 0x, always display it there so that it doesn't confuse the browsers. So that's it for this video. Let's continue in the next video, and in the next video we're going to start looking at the parse float. So I'll see you in that next video, and if you do have any questions, feel free to let me know about them. See you in the next video. Hey, and welcome back. In the last part we were looking at parseInt. Now we get to move on to parse float. And the good thing about this, it is not that complicated. You put in a string and it returns a floating point number. So this is not as complex as the other one. You just put in the number. If you just put in the number within there, it will return to you the floating point number. So what is a floating point number? A floating point number is a number that it is either a positive or a negative number. It has an integer part, so maybe 200. So it may be positive or it may be negative, so it can be 200 or it can be negative 200. And then it also has, or it may have, a decimal point. So maybe it can be 200.22. That is a floating point number. Or it can also be a plus, a positive or a negative number that has an exponent. So 2 exponent of 2 or negative 2. So maybe we want to represent 3.99 as an exponent. This would be 3 exponential of negative 2, or rather 399 exponential negative 2 to give us that. So to represent 3.99, it would be, as an exponent, it would be 399 exponential negative 2. So this is also a floating point number. So if a string cannot be passed, it will return not a number. So for instance, this is not passable because this will not give us a decimal number. So in our case, with the pass float, all the numbers must be decimal. Unlike the other one, where we had certain other radices we could use, here we only have decimal numbers. So it's a decimal number. So this cannot be passed into a number, and this will return not a number. So if this cannot be passed, it will return not a number, and then it will return up to the possible point where it can actually get a real number. So for example, in this case, it's going to return this up to this point. It will return it up to this point, and then it will ignore all these other parts. So it will return it up to there because at least this makes sense to this function. So let's see an example with this, all of this in one long example, and then we can end the video. So if I come back to Scratchpad, I will delete all this. So this one is now pass float. Now pass float, we don't need the radius. So pass float, this one, display, it will give us that. If it is 9 and then maybe exponential of 3, then we display, it will give us that. Then maybe it is 9.33 exponential of 3, display, it will give us that. Maybe it is just 9.33, it will return back that. Let me remove this, and then maybe it is 123 e negative 23, and then with the space, if we display, it will return this. So if we reduce this maybe to exponential of 4 and we display that, at least it gives us something that is like that. So it returns it up to the point that it can. So if I say 845 exponential of negative 3, and then exponential again of 32, 34, it will return it up to the point that it can. So if I do this, it will return it up to that point only. So it's going to be 0.045. So if I display this one, 0, oh, come on. So if I come here and I display that one, it will give us 0.045. And if I add a space in there, it will only give us up to the point that it can. It cannot pass a space. And therefore, if I display the result of that, it only brings back 45. And if I make it something that is not understood like this can be maybe this is a hexadecimal number and you try to put it here to convert it into a floating point number using the parsefloat function. This will give us not a number because this number is not a decimal number. So if I display that one, it will give us not a number. And if I start with a space, let me say I start with a space 2 space 4. I start with a space and then I try. Let me first of all remove all these other results. Then I try to display that. It will ignore the first space and give us a number, but it will not ignore the next space. The next ones are not ignored. So bear that in mind. So it ignores even symbols. If I come here and I say 2 plus 4, maybe times 4, and I come here and I try to display this one, it will ignore all these others because they are not numbers. It just brings back up to the point that it can. So that's it for this video. In this video we have seen how the parsefloat works, and this one is much easier to use because you just put in the number in there. You don't have to use any radices. It just brings back a float. So it brings back a float, and we've said that a float is a decimal number. It has a decimal function, a decimal part, a decimal number in this case, and then you can have the decimal point, and then you have the fraction part, which in this case is this one, and it can be a plus or a negative, or it can just be a decimal number plus or negative like it is here, and then exponential of a plus or a negative number here, like -2 exponential 2 or negative or positive 2 exponential 2. So that's it for this video. If you do have any questions, feel very free to let me know and I will answer them for you. I'll see you in the next part, and in the next part let's start looking at literals, JavaScript literals. Literals are just the actual digits or numbers that you use in your function. So instead of using a variable is equals to 2, this 2 is a literal. So see you in the next section. Hi and welcome back. So in this section let's start looking at literals. Literals represent the actual values that you use in the code. These actual values are the values that get computed. For example, if you have a number like 2, this is an actual value. Maybe the statement says 2 plus 2. These are literals. These are actual numbers. Maybe you have something that gives out a statement like hi. This is a literal. So literals are the actual values. So we have different types of literals. We have integer literals that refers to the numbers. Maybe 2, it can be -4, -1 million, different kinds of numbers, integer numbers. Then we also have floating points. Now floating points, these are numbers that have decimals. So 2.11, that's a floating point number. It can also be in the form of an exponential. So 2 exponent or exponential of maybe 4. This is the same as 2 over 1, which essentially is the same as 0.00, then another 0 there, 2. So that's a floating point. It has a decimal and a number that follows the decimal, or the follow of the decimal can even be 0. This is also a floating point number, and it can have an exponential or it can be a fraction. So this part is a fraction. Then we have strings. A string literal. A string literal contains one or more characters. So in this one we said hey, hi, that's a string literal. My name is somebody, blah 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 blah, that's a string literal. Then we have booleans. Booleans only have 2 possible values, And these two possible values are either true or false. Then we have arrays. An array literal, this one has a group of elements. Different elements can be numbers. In JavaScript, they can be a mixture of numbers and letters. It can even be a statement in there. So that's an array. We are going to look at each and every one of these. Each of them. Then we'll also look at object literals and regular expressions. So objects are key value pairs. So maybe you have an item there, key 1, and then the value. So we are going to look at each and every one of these. So that's an object. Then we have regular expressions. So regular expressions, these are patterns used for pattern matching. Maybe you have a statement that says, my name is X, and you want to match name. You want to make sure maybe name has a capital N. So there's a way you can do that using regular expressions. And maybe you want to return back something, maybe return name. So essentially you can use regular expressions for patterns, and you're going to see how instrumental they'll be in your career as a programmer. They're very instrumental, and once you learn them, you're going to like them. So that's it for this video. I will see you in the next video when we get started looking at integer literals. See you then. Hi, and welcome back. We know that integers can be expressed as a decimal, a hexadecimal, or octal, or binary. A decimal number, this is one that has 0 to 9. So you remember in one of the last videos, we said something about radices. So if you remember, a radix, that is the possible numbers that are possible in any number within that number system, within that numeral system. For example, if you want to write 9 billion, you can only define 9 billion from 0 and 9. So it will maybe be 9 billion and a bunch of zeros there. If you want to write 1 million and something, you can only use numbers from 0 to 9. That is in the base 10 number system. Then hexadecimal, these are numbers that come from 0 up to 9. And then from 9, it goes from A until F. And then in the octal system, the numbers can only use numbers from 0 to 7. And in the binary, we only have 2. That is 0 and 1. These are the only numbers you can use to express any number within this numeral system. So that's what these are. And these are the different kinds of integer numbers that you can use for defining any kind of a literal in your program. So in most cases, you'll find that you use decimals. Yeah, actually, all over the world, most places, the number system that is used is a decimal, whereby you can define any number from 0 to 9. If you want to write 19, it will be 1 and 9. If you want to write 22, it will be 2 and 2. So if I come back here to the browser, and I have this variable tax, and I've given it an initial value of 15. So in this case, the literal value is the integer 15. So if I come down here, and let me just say I use the value of VAT times 2. Then display the result, okay? Oh my god, I can't even see. Yeah. Let's say tax. It's not VAT, it's tax, right? So tax times 2, and then I display. So that's 30. So if I decide that I want to use this number as let's say we use it as a hexadecimal number. And as a hexadecimal number, we can only define numbers from A until F, A to 9 and A to F. So the equivalent of 15 in the hexadecimal number system is f. 15 is the same as f. So if I come back here, how do I tell the system? How do I let the system know that this number is a hexadecimal number? The way that I tell the system that is by using 0 and a small x or a capital X. And as soon as I do this, the system is going to know that this number is not like any other number. This is a hexadecimal number. That's how it will be translated in the system. So if I do this same calculation of tax times 2, we should be able to get the same result. This is f. So if I do the same result once again and display, yeah, it should give us the same result as we had found when it was 15. So let's continue in the next video, and in the next video let's go deeper into more about this. So in this video I just wanted to do an introduction of integer literals, whereby we know you can use your number as a base 10 number, or you can even use numbers as hexadecimal, or you can even use numbers as octal, or you can use them as binary. As long as you let the system know, they will be translated and used accordingly. So let me see you in the next video, where we'll continue from here. Hi, and welcome back. So in the last video, we intimated things about integer literals, and we said something small about decimal and the hexadecimal. Let's go one step at a time and see how we can represent each of these different number systems in our JavaScript code. So we are going to start with decimal. This one is very easy, how to represent a decimal number in your code. As long as you have any digit, one or more digits without a leading zero, 1, 2, maybe the number is 100, maybe the number is 109, maybe the number is 221. As long as it doesn't have a leading zero in front of it, and we're going to see why this leading zero is a very important thing not to have. So you can represent a decimal number. So if I say 12, let's start with a number like 12. Then we say display. You see, it just gives us 12. So you can do different things with this. You can multiply it with a different number. You can add it to another number. You can multiply it by itself, add it to itself. The important thing, no leading zero to represent a decimal integer literal. And then let's go to octal. This is where the leading zero thing is very important. So you can say here, this one, the octal, to represent an octal number in your code. This one has a leading zero, or a leading zero with a O, or a leading zero with a capital O. So this is a small o, and this is a capital O, and can only contain digits from 0 to 7. So let's see why this and this can be confusing. So if I come back here, and this one is 12, right? What if I come here and I add 0 at the front of it? If I add 0 at the front of it, let's see the value that we get. So if I display, you see that tells us that the number there being held is 10. So that means that this was interpreted as an octal number. So an octal number, it will have a number from 0 to 7, and it can start with a 0, or a 0 and a small 0, or a capital, or a 0 and a capital O. I mean, not a 0 but a O. So you see, this is very important. So you can see why this is so important. If you were doing some kind of a computation and you added a 0 in front of a number, it could easily have been interpreted as an octal number. So just a recap, we've seen that a decimal number, it can be any number, one or more digits with no leading zero. So you have to note it's a digit. It only contains numbers from 0 to 9. It can only contain digits from 0 to 9 with no leading zero. So that is a decimal number. And then this one, octal number. An octal number, you can represent it with a leading zero or a 0 and a small o, or a 0 and a capital O, and can only contain digits from 0 to 7. So like we saw with this one. So it can also be like that, and if we try to run that, we say display. You see, it gives us 10. That's it for this video. Let's continue in the next video, and let's continue looking at integer literals and how they can be represented in the different numeral systems. So I'll see you in the next video. Hi, and welcome back. So in this video, we want to continue from where we left off in the last video. And in this video, let's see something that can help us understand this from 0 to 7 with the octal numbers. So if we come back here, let me just remove all of this, delete, and you can see this one's, that's an O, not a 0. So if I display that, you see it's 10. If this is 7, this number is going to get interpreted as an octal number because the numbers here are all represented from 0 to 7. So if I display this, this number is equivalent to 15. Let's say we have 1, 2, 3, 4. This number, the way it is, if we try to display it, it is equivalent to 679 as a decimal. So this number was interpreted as an octal number. What if we change this into 8? And bear in mind that here we have this 0. Let's see what happens if we have a 0 and we also have an O. So if I display this number, you can see we get a bunch of errors, and that is because there is this O here. So if I remove this one, this O, and then let me take this one back to 3 so that we can have this shown back to us. Let me just remove everything to clean this screen. And then if I come and display this, you see this value is the same as 743. So what if I come here and I put 8? The number begins with 0. What do you think is going to happen? Bear in mind that we have a rule that says that octal numbers can only be digits from 0 to 7. So that means that if at any point there is a number that is greater than 7, that number, whether it begins with 1 0 or begins with 10 zeros, it will be interpreted as a decimal number. So if I come here and I display this one, it returns back to us this number, and it will return it back as a decimal number because within these numbers there is 8. That means that there is no way this number should be interpreted as octal, because in octal numbers, numbers can only be represented with digits from 0 to 7. I just wanted to talk about that, at least to bring some difference in terms of 0 and that. So always bear that in mind. If you add a 0 before a number, and within this number, there is no number that is greater than 7, all numbers are less than 7, that number is going to get interpreted as an octal number. Let's do one last example before I end the video. So if I say 0, 12 times 0 and 12. So let's say that is a result that you're expecting, and you try to run this the way it is. So you display, you see it gives us 100. That is because in octal, 12 is the same as 10. So always bear that in mind. If you add a 0 before it, there is a high possibility that number is going to get interpreted as an octal number. And that mostly depends on the interpreter that is being used for interpreting the JavaScript code. So the JavaScript engine will deal with it depending on the system that is being used. You must always find a way to remove this 0, especially if a user is the one adding these numbers and you want the number to be always a decimal number. Find a way to always remove the zeros. You can use regular expressions or any other way that you can think of to remove a 0 before the number. Any leading 0, remove it. So that's it for this video, and in this video we have seen a clear distinction between the 0 and the no leading zero in decimal and octal numbers. So in the next video, let's look at the hexadecimal. Even though we had looked at it in one of the last videos, let's just go and look at it again in the next video. So I'll see you in the next video. Hi and welcome back. In the last two videos we looked at the decimal and the octal numbers. Now let's go to the next one, which is the hexadecimal number, which is a base 16. So to represent a hexadecimal number, it will be indicated by 0 and a small x, or 0 and a capital X. So if you want to represent 16, if you want to represent 15, I mean, it will be 0x f, that is equals to 15. If the interpreter sees this, it will know that, oh, this is not a string, but this is a hexadecimal number. It can be 0 and a small x, or 0 and a capital X. So if I come back here, and before I go to the browser, we know that hexadecimal numbers have base of 16. That means there are 16 different digits or characters that can be used to represent any number in a hexadecimal system. So we know if a number is hexadecimal, it can only include 0 to 9, and the numbers that are greater than 9, that is from 10 up to 15, will be represented by A until F. So that means 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and then 15 finally is F. So these are all the possible numbers from 0 to 9, and then A, B, C, D, E, F. So if I come back here to the browser, I'll just delete this entire thing. Let me just remove these ones as well. So if I want to represent a hexadecimal number, it is a 0x. If it is 1a, the interpreter, the JavaScript interpreter, will see this and just know that this number is a hexadecimal. It should be used as a hexadecimal number. So let's see what number this is when it comes to a decimal number. So if I display that, this is the same as 26, 1a. And if I want to represent 10, I can just use A and display. There we go. That's 10. If you want to represent 11, that's B. Display that. You want to represent 12, there. 13, there. 14, there. And then finally 15, and then finally 15, if I run display this, it will give us 15. And if I want to go to the next number, which is 16, it will be 1, 0. That will give us, that's the same as 16. Then I want to go to 17. And then I want to go to the next number, 12. If I display this, this is the same as 18. So if I want to represent the next one, 19, it will be, or rather 19, it will be that. And if I want to represent 20, display 20. So you'll just go all the way like that, and then at 19, you display is equals to 25, and then 20, display is equals to that. And you can even use bigger numbers. So let's say that we want to use a bigger number, 2EF, and then I display that. That's that number. So the point is, if you want to represent a number as a hexadecimal, you can use a small letter x or a capital X. So 0 under x as soon as the interpreter sees that, it will just know that this number, whatever comes next, it should be interpreted as a hexadecimal number. So if we display that, it will give us this number. And now, what if we have something that is not part of the numeral system within the hexadecimal numbers? So that if I try to display this, it's going to give us this error because R is not within A to F. Is not within A to F, and it is not within 0 to 9, which represent a hexadecimal numeral system. So the point of this was this. In your integer literals, you can use a decimal number, you can use an octal number, you can use a hexadecimal number, you can also use a binary number. So we are going to look at binaries in the next video. So the point was that you can use any of these number systems, and you have to know that there's a difference. So for instance, you saw that if you say 0, if you start a number like 0, 1, 3, and you try to do the square of this number, you're going to get a number which is not what you're expecting. For example, you'd probably expect the 013 would give you 169, which would not happen because this number has a leading 0. It would be treated as an octal number, and therefore this number would be interpreted as something different. So let's continue in the next video, and in the next video we're going to look at binary numbers. We're going to look at the binary integer literal, which is base 2. So I'll see you in the next video. Hi and welcome back. So in the last video we saw how you can represent a hexadecimal number within your code. So in this video we're going to look at binary numbers and how you can represent a binary number within your code. So if at any point you want to use a binary number, it will start with 0 and B for binary, or 0 and a capital B for binary still. Even here the O is for octal, and here the X is for hexadecimal. If you want to tell the system right away that the number that we are talking about right now, let me remove all of this, remove everything. You want to represent a number as a binary, you want to let the system know that a number is a binary, you'll just do 0, B, and whatever number it is, 1, 0, or maybe 1, 0, then you display that is 10. Then, let's say we declare a variable, we call it num is equals to 0b 0b 10 10. Then now we can do different things with the variable. Let's say num times num. What result will it give us? 100. We can even change it to 0000001. Then we display which number this is. You can see we can also display the value of num so that we can know which number we are working with. So if I display, you see this is a number that this is equivalent to. In binary numbers, you know, it only has 0 and 1. So at any point within this, if I have something like 2, we know this is going to give us an error. It's going to be an error because 2 is not part. Because we know that 2 is not part of the possible numbers in a binary number. So if I display this, you see it gives us all these errors. If you want the system to know that the number you're using is a binary number, it will start with 0 and a small b or a capital B, and the numbers within it must be 0 or 1. So I hope by now you understand the different kind of integer literals that you can use. You can use a number as a decimal, you can use as an octal, you can use as a hexadecimal, you can use as a binary, and you know how you can represent a number as an octal, that is using 0 and O or 0 and capital O, and as a hexadecimal by using 0 and a X or 0 and capital X. and as a binary by using 0 and small b or 0 and capital B. And as I said, in most cases, you're only going to find yourself using decimal numbers. And with decimal numbers, they're very easy to write. If you want to write 24, no, nothing in front of it. You want to write 30, just that simple. You want to write 20, 30. You don't have to use anything before it or after it. As long as it's a number that contains 0 to 9 with nothing in front of it, it will definitely automatically be interpreted as a decimal number. So that's it for this section on integer literals, and I will see you in the next section. If you have any questions, feel very free to let me know. So I'll see you in the next section.